This is day 18 of Advent of Code 2023, and this challenge is called Lavaduct Lagoon. Thanks to your efforts, the Machine Parts Factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They've asked you to take a look at the dig plan, the puzzle input. For example, got a direction. Okay, so the digger starts in a 1 meter cube hole in the ground. They then dig the specified number up, down, left to right, clearing full 1 meter cubes as they go. The directions are given as seen from above, so if up were north, then right east, and so on. So each trench is also listed with the color that the edge of the trench should be painted as an RGB color. Interesting. When viewed from above, the above example dig plan would result in the following loop of trench, having been dug out from otherwise ground level terrain. So assume it's starting at the top here, so that one's already dug out, then you go 1, 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, and that's how that would work. At this point, the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. So you've got the perimeter, then it also includes everything else in the middle. So now the lagoon can contain a much more respectable 62 cubic meters of lava, while the interior is dug out. The edges are also painted according to the color codes in the dig plan. So how many cubic meters of lava could it hold? Okay, so we'll grab this input, chuck it in here, and we will do this input, and we will do for iron line strip, like that. So let's print out the input. Oh wait, this isn't what I wanted. I wanted for I in r strip dot split. That's what I wanted. There we go. We'll keep the parentheses in there because I'm not sure what part 2 is going to do. So keep that. Then I guess for part 1 we just follow the directions it's giving. So def create perimeter, pass an input, and this will be for instruction in input. Actually, that's probably a good name to call this, instructions. For instruction in instructions, this will be direction distance color equals instruction, and we'll have perimeter. Actually, because it's lines, we could do, I was going to add every single cell, but we could put ranges in here, so, or like the edge of the shape, so edge. So it would be like 6, or we'll start 0, 0 to 06. Yep, so we'll do that with perimeter list, or I guess edges. And we'll do current equals 0, 0. And we'll also do right equals, we'll do 0, 1. Left, 0, -1. Actually, I did this exact same thing in the previous one, didn't I? We'll just copy that, put that here. So then what we'll do if direction equals R, do dir equals right, and we'll just copy that, elif, and we'll just do, initialize this as up, then we can do left, D for down, down. And then what we do, we will do next equals current 0 plus dir 0 times distance, and then we do the same thing for this 1, 1, and then we do perimeter dot append, this will be, we will do that, and then current next. So if we do that, let's print perimeter and then run current in here just so we can see what's doing. So instructions, so let's run that. Didn't work because I forgot to what did I forget to do? Direction distance equals int distance. That's what I forgot. Oh, then I need to also do over here current equals next. So let's do that. 0 to 06. That looks like that's working as expected. So now we'll just say perimeter equals that. Return perimeter. Now I guess the question is, what do we do with this? Actually, looking at this, I don't need to do current. I just need to put next in, because then we can just go to the next index or the previous index to know what it was doing. So let's just remove that. We'll keep next, and we'll do perimeter with this 0, 0, 0, and then we'll be basically just doing, instead of current, it'll be perimeter -1. Oh, perimeter -1, 0. That's what it needs to be. Then -1, 1, and then just perimeter append next. Print perimeter. Let's see if that still works. Okay, I guess that still works. Cool. So we've got all the corners within the shape that we're digging, but now it's a matter of finding the area of it, which I don't actually know how to do because it's an irregular shape. So I'm basically just gonna, actually I should do that here. I'm gonna look it up. How to find area of irregular shape, I guess, maybe formula for finding area of shape with known perimeter. Maybe, what else could we think of? I guess it could be find area of shape from coordinates. Not sure why I turned up to dark mode, but sure. Well, actually, let's take a look at this shoelace formula. So I have a set of points. I would like to know if there's a function that can calculate the area enclosed by a set of points. I'm not sure exactly what it's saying. Let's bring up shoelace formula. It says something. So okay, determine area of simple polygon whose vertices are described by the Cartesian coordinates. Okay, so that looks like what we are looking for. Okay, is this what we're looking for? So how does this work? So I got 1, 6, that's 1, 6, 3, 1, like that. That's 7, 2. Goes back to the start. Okay, how do these groupings work? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So is it, maybe I should just go up and look at, okay, so it's y1 plus y2 times x1 minus x2. So then you plus, let's do a split screen like this. Okay, so we've got the perimeter. Let's do def find area perimeter, and we'll do a equals 0 for now. So we'll do index point in range perimeter up to -1. Is that what I'm wanting? Just to see, let's print this because I want because I'm going to be going up to the last index and going forward 1. So is that does what I think it does. Cool. And then for this, so this will be x equals 0.0 minus perimeter index plus 1, 0. Then y equals the same thing but 1, and then we're adding that all together. I don't know, we'll just do total equals 0. So then it'll be total plus equals x times y. Then a equals total divided by 2. Okay, let's actually try that with this one. So perimeter equals 1, 6. Then we'll do 3, 1, 7, 2, 4, 4, 8, 5. So 3, 1, 7, 2, 4, 4, 8, 5. And then in our scenario, this one will be back here. So let's then run this, find area. We'll just put perimeter in there, even though we're changing it. Then print x, y, and then print a. Oh, then we also want print total. So are we doing that correctly? This object cannot be interpreted as oh, I forgot to do length. Wait. Oh, don't need to do range. It's numerator is what I was looking for, not range. There we go. Now do that. Okay, so I messed up something there. Let's include point and then perimeter plus 1. So what did I miss in this? Oh wait, y should be plus. Wait, this is the area of a pentagon. Okay, it's not that. Or maybe that's, wait, is this just the example? Am I doing this wrong? Maybe I should just look up Python shoelace formula. If I could spell formula correctly. I don't want NumPy solutions, I just want to normal. Okay, this looks like it. So I got polygon. So find range J. Okay, that's so it's wraparound, so see area. Did I just misunderstand how that worked? Wait, I0 times J1. Is that, did I just completely misunderstand how, say I0. Oh, okay, yep, so I0 times J1, that's this, minus these two. So if I do this, does that then work? Alright, this is times. Okay, then these are all added together, so total plus equals x, total minus equals y. Although I'm using the wrong, it shouldn't be x and y, but whatever, we'll just keep it as that. So now if we do that, okay, so it's working on this one now. So if we now get rid of that, and we use our actual one, okay, we're getting minus. Am I missing something? Actually, what is the answer for that one? 62. It's possible that because this is already a 1x1 cube that we've dug, we might need to expand it a bit more. Maybe we'll do starting area equals def gets def starting area instructions. Then we'll just kind of do the same thing here. Starting area equals 0. Starting area plus equals distance. Then return starting area. Okay, got that wrong. Okay, we'll just change that to area. Got instructions. And we need to turn that to int. So yep, 38 is the initial starting area. Then we're doing maths on top of that. Is there a chance this is wrong at all? Create perimeter. So it's this times this. So this seems to be correct. So getting the correct stuff for it. For perimeter. Don't need that. Okay, there must be just a different algorithm that we need for this. Let's try shoelace formula coordinates something. So let's go back to like this. x0 times y0 minus this. Okay, so we're doing, let's do x0 y1 x1 y0, let's just call it that. So we got this x0 y1, which is this times this, which is correct. Negative 42. What are the chances that's meant to be the other way around or something? Okay, well that makes it positive. I guess we'll just keep like that for the sake of having it positive. Although doing absolute would have fixed that anyway. So that gives us 42. Okay, so what do I need to do now though? So say we've got 42. That number relate 62. So there's a 20 difference. So 42, 38. So these two need to be, there's some math that needs to be done with both of these numbers to get the whole area. Because we have the perimeter area, which is all 1x1 cube. Then we've got the interior section, which is this. Obviously adding them together doesn't work because that gets, what, 80 or something. Inner area equals find area. So there's something we need to do here. Turn area plus perimeter. This is wrong, but let's just look at it. Although first we'll print area in area, just so we can see the numbers. Oh, in area, my bad. 38, 42, that returns 80. If we divide by 2, that would make it 6, no, not 16, 19. It would make it 19, which when you add, that would make it 61. Plus 1? So that's 62. I feel like that could be it. I don't know why. But you know, getting the numbers, dividing by 2, adding 1, that's something that could work, I guess. I don't know, let's try that. So let's add this back. 33491. Oh, that is the correct answer. Cool. Okay, well now on to part 2. The elves are right to be concerned. The planned lagoon would be too small. After a few minutes, someone realizes what happened. Someone swapped the color and instruction parameters when producing the dig plan. They don't have time to fix the bug. One of them asks if you can extract the correct instruction from the hexadecimal codes. Each hexadecimal code is 6 hexadecimal digits long. The first 5 hexadecimal digits encode the distance in meters as a 5-digit hexadecimal number. The last hexadecimal digit encodes the direction to dig, 0 meaning right, 1 down, 2 left, 3 up. So in the above example, the hexadecimal codes can be converted into this instruction. Okay, last digit is the direction, then convert this. Okay, so digging out this loop and its interior produces a lagoon that can hold impressive cubic meters of lava. Okay, so is that just the same thing? Okay, let's change to this. Part 1 create perimeter, and then we just do a part 2 one. Okay, so let's grab this and just do part 2. So perimeter is this, instruction, got color. So I guess I'll just keep it named as color. Actually no, so we'll do hex equals instruction 3. Hex equals hex dot replace that with this, dot replace that with this, and then dot replace that with this. So let's just print hex to make sure that's working. Okay, part 1. Let's just comment that out for now. Comment everything out for now, I guess. Instruction 2. 70, is that correct? Yes, it is. So now we do direction equals hex -1 and distance equals hex up to -1. So now let's print distance direction. Okay, looks correct. And I don't know, Python convert hex to decimal. Don't think I've ever actually done that before. Oh, okay, so it's just int the hexadecimal value and what base it's using. So now distance, we'll do int this base 16. Does that work? 461937. Yes. And then what are the numbers? So 0. Let's just grab this. Okay, so undo that part. If direction equals 0, it's right. If direction equals 1, it's down. If direction equals 2, it's left. And then do it like that. Did that just work instantly? Oh, that is a different number. Okay. 5240. Then it gets wrong there. Okay, well, I don't know how to fix that. I don't know, print perimeter, do we have the correct numbers in there? So it does end up at 0. Maybe starting area? Starting area, that's where, I forgot. So I think it's, copy this or something. That's part 1 starting area. Part 2 starting area. Starting area 0 for instruction. Hex equals this. Hex replace this. And then distance is this. Now let's rerun it. Oh yeah, I need to rename those. Starting part 1, part 2. None type an int. Print area. Did that return none? It did. Okay, so what's going on here? Oh, we forgot to return starting area. Ugh. Okay, is that the correct number? 1, yes, okay, that's the correct number. Now let's go to the actual import and run it. Oh, and that's a massive number, which we'll paste into here. Oops, and submit. Oh, awesome. So that's part 2 done now. So that is day 18 of Advent of Code 2023 completed. If you like this video, make sure to like and subscribe so you don't miss out on me completing the rest of these challenges.